Hello students, in today's class we are going to learn a new topic and which is very interesting and very important topic called Venn diagrams. These kind of diagrams you might have come across in many of your competitive exams, and it's very easy and which is very important in set theory. This is named after an English logician called John Venn, and it consists of rectangles and closed curves, usually circles, and the universal set is always represented by rectangle and its subsets are represented by circles. Yes, so let us see one example how to represent the given example universal set and its subset. As I told you, universal set is expressed inside a rectangle. So imagine this is your universal set U, and I am going to represent the subset of A is a subset of U, right? Now we are going to represent A by the circle, and elements of every set is represented within its circle. So first fill in the elements of the subset so that the remaining elements we can fill in the remaining places. Now the elements of A are 1, 2, 3. What are the remaining elements? 4, 5, 6. So 4, 5, 6 you can write anywhere inside the rectangle. Now if you analyze this diagram, this circle is inside the rectangle. So the entire region of the rectangle is the universal set. Now 1, 2, 3, 4, 5, 6. All the 6 elements are inside the rectangle, which means all the 6 elements are the elements of the universal set U. And if you analyze the subset of U, it has only 3 elements 1, 2, 3, where 1, 2, 3 are the elements of the subset A. Right? This is how we will express the given sets using Venn diagram. On the other hand, if the diagram is given, you should able to identify the elements of the given set. So which are the elements lies within the space of that particular curve or figure, then those elements will lie in that particular set. If you analyze this, first list out the elements of the universal set. So what are the elements in the universal set? Universal set, as I told you, we will represent using rectangle. First write what are all the elements inside the rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the elements are inside the rectangle only. So 1 to 10 will comprise the elements of the rectangle. Now let us list out the elements of set A. Now set A is the bigger circle. Now see what are all the elements are inside this bigger circle. 3, 1, 2, 9, 8, 4. Why are we writing the elements which is inside the smaller circle even? Because that is also inside the bigger circle. So the entire space of the bigger circle is for set A. Even though it is there in B, it is also there in A. Therefore the elements of A are 1, 2, 3, 4, 8 and 9. Hope you understood. Then what are all the elements of set B? List out the elements of set B. Set B is the smaller circle. What are the elements in smaller circle? 1, 2 and 9. So B 1, 2 and 9. So on looking at the diagram, we can very well list out the elements of the set. On the other hand, if the elements of the set is given, you should able to express it using Venn diagram. Okay. Now on seeing the diagram, even we can conclude that B is a subset of A, because the set B is completely lying inside the set A, right? Therefore B is a subset of A. Instead of listing out and finding whether it is a subset or not, on the diagrammatic representation itself we can conclude which is a subset of which set. So we can conclude that B is a subset of A and A is a subset of U, right? So we can write B is a subset of A and A is a subset of U. Next we are going to see operations on sets. As we have some arithmetic operations on numbers like addition, subtraction, multiplication, division, we have some operations to be performed on sets also. So we are going to learn 3 types of operations: union of sets, intersection of sets and difference of sets. So first let us see what is meant by union of sets. From the name itself we can understand it's union. Union means combining all the elements. So when we find the union of two sets, it will consist of all the elements of both the sets A and B. For example, if you are going to find the union of set A and set B, then A union B will have all the sets which are available in set A as well as in set B. It is denoted by this symbol. This is not U, this is a symbol for union of sets. For example, if we write it as A union B, which include the set of all x such that x belongs to A or x belongs to B. Understand it, or. What is the meaning of or? The element can either available in A or in B. It is not necessary that the element should be available in both the sets. If it is available in both the sets, then that collection will be called as intersection of sets that we are going to learn in the next step. So understand the meaning of or. Union will contain the set of all x such that x belongs to A or x belongs to B. It can be in any one of the set. Now let us see one example. If A is equals to 1, 2, 3 and B has the elements 2, 1, 5, 6, then mathematically how we can find A union B? A union B will include all the elements of A as well as B. So first write the list out the elements of A, then I am going to list out the elements of B. But when I see the element of B, it again has 2. 2 is already available in A. As we know, the basic definition of set itself says the elements are distinct. That is, there is no necessity for repetition, right? So we are not going to repeat this 2 and 1. Then move on to 5 and 6. So A union B include the set of all x such that x belongs to A or x belongs to B. This is called union of two sets. Now through Venn diagram, how we can express this? As I told you, the universal set we will express it using what? Rectangle, and we are going to represent a set A by one circle and the set B by another circle. So this I am going to represent it by A and this I am going to represent it by B. Why this overlapping? Why we represented two circles by overlapping? Because there are few elements which is available in both the set A and B, right? So that's why we have drawn two circles with intersection, right? Now if this is set A and if this is set B, if we want to represent the elements here, how you will represent? First write the elements which is common in both A and B. Which is common in both A and B? 1 and 2. 1 and 2 is available in both the sets. So you can write it in this common area. Then which element is available only in set A? 3. That I can write it here because this region is only for A. Because this circle is fully A, but this region is only for A. This inside region, this in between region is for both A and B, right? So I have written elements which is common in both A and B. Hope you understood. Then this region is only for the set B. So write the elements which is only available in set B. Right? Numerical values if you want to represent in Venn diagram like this only you have to represent. But without any values in general, there is a set A and B, then how you will represent the union of two sets? Means A, B and this is union. Then by shading, how will you identify the union of two sets? This is the region of A union B. Because the region of A union B should include the region of A as well as the region of B. So this represents A union B. This is the representation of A union B through Venn diagram, right? Before getting into intersection of two sets, I wish to state two other possibilities for A union B. This is the possibility where the set A and B have few elements in common. It is not necessary always two sets should have some elements in common, right? So there are possibilities where two sets does not have any element in common. In such case, how you will express it through Venn diagram? See, this is the universal set and this is set A and this is set B. This is set A and this is set B and this is universal set, right? They do not have any overlapping, which means they do not have any elements in common. In such a case, what will be A union B? The set A fully and the set B fully. Understood? There can also be some other case where the completely set A may be the subset of set B. In such a case, how will, as we saw here, right? In this case, set B is completely the subset of set A. In such case, what will be the result of A union B? How you will show it? See, suppose if this is set A and this is set B. This is set B and this is set A. Now here B is a subset of set A. In such a case, what will be A union B? Again the entire set A. The entire set A. If you list out the elements of set A, obviously it will include the elements of set B even, because set B is completely lying inside set A. B is a subset of A, right? So the region of A itself will give you A union B, right? Hope you understood. There can arise three cases. It is not necessary always set A and B, set B should have some overlapping. It can, or it may or may not. So you should know what will happen if there are overlapping, if there is no overlapping at all, or if one set is completely inside the other set, right? Hope you understood. Now we will move on to the second operation, intersection of two sets. What is intersection of two sets? Which are common to both A and B. The elements which are available in both the set A and B is called the intersection of two sets, and it is denoted by inverted U. Here union is denoted by the upward open U, right? The first letter U, union U, and intersection is denoted by the inverted U. A intersection B. Then A intersection B will include the values, the set of all x such that x belongs to A and x belongs to B. Understand the meaning of and. There we told or. Or means it can either be in A or in B, the set B. Here and, it should be available in A as well as in B. It should be available in both the sets. Only then it will come under intersection of sets. If it is not available in any one of the set, then that particular element won't come under intersection of two sets. Right? Now let us see one example. We have taken the same example to make the concept clear. Right? Now A is equals to 1, 2, 3 and B is 2, 1, 5, 6. Then what are all the elements will be there in A intersection B, which is available in both the sets? Here we have 1, here also we have 1. So 1 will fall under A intersection B. Here we have 2, here also we have 2. So 2 also will fall under A intersection B. Here we have 3, but which is not there in set B. In set B, we have 5 and 6, which is not there in set A. Therefore, 3, 5 and 6 won't come under intersection of two sets. Yes, hope you understood. Let us see how we can express it using Venn diagram. Now, again, as usual, the rectangle represents the union of two sets, and this is A and this is B. If you want to represent the elements, how will you represent? In the same way. The intersection part, you should write the elements which are common here, and the remaining elements only 3 will come here in the A region, and here 5 and 6. Since we have taken the same example, the same values. Now let us see how we can represent A intersection B through Venn diagram. Now this is A. Again we will see 3 cases here. If there is some overlapping, few elements are available in both A and B and few elements which are not available. So if there is a overlapping for A and B, how you will represent A intersection B? A intersection B is the region which is common in both A and B. Right? Now if suppose there is no overlapping at all, which means the two sets A and B are completely two distinct sets, then what will be A intersection B? A intersection B, the definition of A intersection B says it should be available in both the sets, but this is the case where we don't have any elements in common, right? That's why we have represented like this, two distinct sets, which means A intersection B here is null set. We cannot shade anything here. So this is what the representation of A intersection B. Diagrammatically we will represent like this. Mathematically, if we want to write, we will write A intersection B is equal to null set. It doesn't have any elements, right? The third case, if one set is a subset of the other, say this is set B and this is set A. Now B is a subset of A. Then what will be the intersection here? A intersection B. A intersection B will be the entire set B. The entire set B alone. This region won't fall under A intersection B because this is only for A. This is not for B. But this region is for B as well as for A, right? So this region alone will fall under A intersection B. Hope you understood. Yes, analyze the diagram properly and understand the things. These are all virtual ideas only. Only if you get into deeper and analyze it, you will get a better idea. So don't watch it, don't see superficially, right? So analyze it properly. This smaller circle denotes this area of the smaller circle denotes the entire set B, and the area of the bigger circle denotes the entire set A. Now we are talking about the elements which is available in both A and B, which is the region which is common for both A and B. Which region is common for both A and B? Only this region. Therefore, A intersection B will be represented like this. Yes, hope you understood. So far we have seen two operations on sets, union of sets and intersection of sets. Next we are going to see what is meant by difference of two sets. Next we are going to see difference of two sets. What is meant by difference of two sets? Difference of two sets A and B in this order. Underline this word, in this order. This is very important. In this order. In this order means A is your first set, B is your second set. When you are taking A as your first set and B as your second set, the definition of difference of two sets will be elements which belong to A but not to B. So which means the first set plays a priority here. The first for the first set you should give more preference, right? So difference of two sets A and B in this order will be elements belongs to A but not to B. So difference means as usual it is represented by the symbol minus. So A minus B will be the set of all x such that x belongs to A and x does not belongs to B. This you will understand with the following example. For example, if the set A has elements 1, 3, 5, 6 and 7 and set B has elements 2, 3, 4 and 5. Then what is A minus B? The definition of A minus B says elements in A but not in B. So the first step is find the intersection. Find the intersection of two sets. Which is intersection? See, both the sets has the element 3 and both the sets has the element 5. And 1, 6, 7 is not there in set B and 2 and 4 is not there in set A. So first step, find the intersection of two sets. Now A minus B will be the elements, remaining elements of set A, 1, 6, 7. That's what the definition says. A minus B is equals to the set of all x such that that particular element should be in A and not in B, which means it should be available only in set A. Only in set A, which means since we have written A as our first set, it should be available only in A. If we want to find B minus A, then it will have the elements which is available only in set B. Right? So what will be the answer for B minus A now? B minus A will be 2 and 4 because 2 and 4 are the elements which is there in B but not in A. Right? Hope you understood. A minus B means the remaining, the elements which is available in A but not in B. B minus A means the elements which is available in B but not in A. Now let us see how we can represent this using Venn diagram. So the rectangle will represent the universal set, and here also we will check out many cases. Now first, as usual, we will go with the overlapping of sets, and this is A and this is B. Then what will be A minus B now? A minus B, the elements which is there only in A and not in B. Right? Now if this full circle represents the set A, but this region is there in B even. So this is the region which is only in A and not in B. Therefore this represents A minus B. Right? Suppose if we have two disjoint sets, in the sense two sets which does not have any intersection, A and B, then what will be A minus B? A minus B is only set A, because it doesn't have any elements in common, right? So the entire set A will fall under A minus B, right? Suppose if one set is a subset of the other, this is your A and this is your B. This is your A and this is your B. Now what will be A minus B? Again imagine the full circle, bigger circle is the region of A and the smaller circle is the region of B. The definition of A minus B says the region which is only for A and not for B. So which will come under A minus B now? This is your A minus B. Suppose the other case, if A is a subset of B, then what will happen? Imagine the bigger circle is your B and the smaller circle is your A, and again you want to find out what is your A minus B. In this case, what is A minus B? Here A minus B is the null set, because the entire A lies in B. The entire A lies in B. So there are no elements in A which is not available in B. Therefore, in this case, A minus B is null set. We don't want to shade any region here. If you don't understand, I'll explain this with numerically. Suppose if A has the elements 1, 2, 3 and B has the elements 1, 2, 3, 4 and 5. Now A is a proper subset of B, right? All the elements of A lies in B. Now in this case, what will be the answer for A minus B? Now as I told you, first step, find the intersection. All the three elements are available in set B. So A is left out with no elements, right? So A minus B is null set. Hope you understood now, right? So in some cases, if we are unable to represent it diagrammatically, immediately you frame out your own example and check out and then represent it diagrammatically. Right? So far we have seen three operations on sets: union of sets, intersection of sets and difference of sets. Union means all the elements which is there in both the sets will fall under union. Intersection means which is common in both the sets, only will be there in intersection. The difference means whenever we say difference, we will give priority to the first set which we are talking about. So first we will find out the intersection and the remaining elements in the first set will fall under the difference, right? If we say A minus B, we will give preference to set A. If we say B minus A, then we will give preference to set B, right? Next we will see properties of two operations, union and intersection. We know already, we have seen all these properties on integers, whole numbers, right? So the same properties we are going to see whether it is applicable for the operations on sets. First one is commutative property. Commutative means union is commutative. A union B is same as B union A. Similarly, intersection is also commutative. A intersection B is same as B intersection A. Next property is associative. Associative is for three sets, right? The same operation can be extended for three sets even. We will be seeing while solving problems. So A union B union C is same as A union B union C. The same way intersection is also commutative. Then identity. Which is identity here? Null set will be the identity. So A union null set will be what? Union means it should contain all the elements, right? So when you union the set A and the null set, you will get the set A as your answer. When you intersect with the null set, then none of the elements will be in common, so you will get null set as your answer. Then idempotent, this is new to you, right? So in the previous classes we have learned commutative, associative, identity and all, but idempotent is new to you. Idempotent means the operation which is done on the same set, the operation which is done on the same set to itself. For example, see A union A. If you find the union for the same set, what answer you will get? Same set as your answer. Intersection also the same way. You will get the same set as your answer. Then law of U. U means universal set. What happens if you do union and intersection with the universal set? So U union A will be when you combine the entire elements in the universal set, you will get, right? So universal set will be your answer. When you do intersection with A, you will get only the A as your answer. So intersection will be always minimal, union will be the maximal. The last one is distributive. This is distributive, intersection over union. So A intersection B union C is nothing but A intersection B union A intersection C. So far what we learnt in today's class. In today's class we learnt about Venn diagram. We have seen how to represent the problems using Venn diagram, and we have seen three operations on sets called union, intersection and difference, right? And we have seen few properties on operations of sets. Do these problems from exercise 1.4 as homework. We will continue the remaining things in the next class. Thank you, students.